Get started? Wow.
Hi.
Good afternoon, everyone. Welcome to the last talk of NDC 2019. I hope you guys have had a good conference so far. I certainly did. I enjoyed lots of talks. I particularly like the ones on cloud and architecture, the ones on Kubernetes and Docker and things like that. And I got nothing against any of them. I particularly like them. But a lot of use case scenarios, something like a serverless architecture is a lot more simpler and a lot more easier to use. And the reason for that is just not the simplicity of it. Even the cost modeling works quite well when you're dealing with serverless. And a lot of startups actually prefer working in this stuff. And of course, with something like serverless technology, pretty much most of the stuff is taken care of by the cloud vendor. Things like how you do your scaling, how you do your patching, and things like that. But one of the things that you really need to worry about is security. And that's what this talk is all about. My name is Mahesh Krishnan. I work for AGL Energy, and I've been working in cloud and architecture for a number of years now. I used to be a cloud Azure MVP for about 4 years or so. And my co-presenter is Pratik. Pratik also works at AGL. He's one of the cloud solution architects. And one thing, even before I get started, I'll say is that we're going to be talking about serverless security, and we're going to be focusing primarily on the Azure cloud. But the concepts that we're going to be talking about will translate quite easily to any of the other cloud providers as well, whether you're using AWS or Google or any of those things. Anything that supports serverless, you'll be able to use those concepts. So what the hell is the serverless architecture itself, right? If you look at, I suppose, like Martin Fowler's description of it, he basically says serverless architectures are application designs that incorporate third-party PaaS or backend as a service, and this is actually exposed through custom code run in managed ephemeral containers as a function as a service. I mean, it's a lot of words, and I can keep reading on that. But in a way, if I were to explain this with a simple diagram, right, you effectively have, in most of these architectures, you have like a single-page application. So you got your HTML and your JavaScript and everything else, and they end up calling an API. And this API is basically runs as a function in a serverless fashion. That's your function as a service. And these functions as a service end up calling some kind of a backend services or backend as a service. This is where you may have some kind of a NoSQL database or even a SQL database. But pretty much these days people are more leveraging towards a NoSQL database to represent the data in this case. And that's all it is. It's a very, very simple architecture.
And one thing is that if you look at this very simple architecture, a SPA application, the application running on your browser is not running on a server, so you don't need a server for a SPA application. The SPA application we're going to show you a very simple one JavaScript file, but it can be an Angular application, or as we saw in NDC today, the new thing that is coming out is Blazor WebAssembly, the client deployment model, which is also a single-page application. You don't need a server to run that. Our client machines are quite powerful. The browsers are quite powerful now. They got very good JavaScript engine that can run the application right on the desktop. For Azure functions, they're also serverless. They scale on demand, very, very cost effective. You pay per consumption, per call. And backend as a service, again, like things like
table storage.
Table storage in Azure is a very good solution. Like Troy Hunt runs a billion queries from a table storage. And even with other vendor, you got like Google Firebase or Amazon DynamoDB, they all fit into that category called backend as a service. If you want to be a little bit more fancy, a proper database, you can use Cosmos DB, which is pretty much a backend as a service as well.
Yeah, absolutely. And one of the key things, right, we keep talking about serverless and so on. There are a couple of key things that I want to mention about it. One is the fact that when you're talking about serverless, it doesn't mean you got no service, right? I mean, obviously the cloud vendors are running in a server. But that is completely abstracted away from you, and that's one of the key takeaways of this run, right? Is that it means that you don't have to manage these servers. These are managed by the cloud vendor. They take care of things like scaling. You just basically, it's based on consumption. You make as many calls as you want, and you just pay for what you use. You don't have to worry about things like patching these servers and so on and so forth. But like I called out earlier, you still need to manage the security, and it's going to be a key part of it. And I like this particular diagram that Amazon have put out, right? They talk about this shared responsibility model. And what they say is that cloud vendors like Amazon and Google and so on, they're responsible for the security of the cloud. Whereas you, and they call it customer, customer is effectively all of us who are deploying applications in the cloud, we are responsible for the security in the cloud. So if you think about it, the customer's data is your responsibility. How you authenticate the user is your responsibility.
Yep.
How you actually secure the data, the security of securing the data while it's in rest and transit, encrypting it, all of these things are your responsibility. The cloud vendor, on the other hand, takes care of everything else. The security of the infrastructure is their responsibility. In the case of things like function as a service, the operating system or the containers that actually run these functions are also their responsibility. If they need to patch these things, they will actually do it for you. So, in a way, it is a shared responsibility, right? But again, when you think about it, when something actually goes wrong, whether if you're running it in Amazon or Azure and things like that, if something goes wrong from a security point of view, you are the one who's going to be responsible for it. So you got to make sure that from an application perspective, there are things that you need to worry about. If there's cross-site scripting attack or SQL injection attack and things like that, those are things that you still need to take care of.
I mean, oftentimes we are delivering in agile mode. We are doing sprints, we're pushing the code out for our business functionality, the business values. And sometimes security can take it can fall on the wayside. We're not very, focusing on that one. But it's actually very important because even with Australian laws, you are responsible for your customers' data, your enterprise's data. Even if you outsource some of the responsibility to cloud, but the end responsibility begins with you. So you really need to think about security when you are doing your application. There are some tips that Mahesh will go through on how it can help you with it.
So if you look at real quick security 101, there are three things that we actually talk about in terms of security. We talk about this as a CIA triad: confidentiality, integrity, and availability. Right? Confidentiality is a thing where if you put your data up in the cloud, you're quite the data is not being accessed by someone who's not supposed to access it. Right? Number one. The second thing is about the integrity of the data. That the data that you put in isn't being modified by someone who's not supposed to be modifying it. And the third one is availability of the data. Is whenever you need the data, the information, it's actually available for you to use. Now, those are the three things that we actually focus on in security itself, right? And so, if you look at app security practices itself, if I want to, when I talk about security 101, I'm giving this in, let's say, less than a couple of minutes, right? There are certain things that you want to do. Is like the first time is like every application is different. So, most applications, we want to start doing some kind of a threat model for your application itself. We focus on things like a stride to kind of like determine what kind of threats your application will be facing. Stride actually stands for spoofing identity, tampering data, repudiation, information disclosure, and elevation of privileges. So you look at your application itself and then figure out what kind of threats your application has. Once you identify these things, there are several threats that actually your application can have. And OWASP, for instance, publishes like the top 10 threats that are available. And you look at it every time they actually release it, you'll have some things that keep appearing over and over again. Things like SQL injection or cross-site scripting and so on. So it's up to you to actually fix these things. And OWASP also publish a whole bunch of guidance. If you go look at the OWASP ASVS, there's a whole bunch of guidance on what you can actually do from an application perspective to make sure these threats are actually handled in a good way. You also need to make sure that you follow good engineering practices in terms of security itself. And once you've actually done all of these things, large enterprises will start to do things like vulnerability testing. And you can also run your code through, as part of the build pipeline, run through some tools that can actually do some static and dynamic checking. And that can find vulnerabilities in your code as well. Now, the things that I'm actually talking about is effectively like the basic hygiene in terms of security itself. So we're not going to, in this talk about things like how do you do, how do you prevent your application from SQL injection and cross-site scripting and things like that. But we're going to talk at an overall level on how you secure your application, a serverless application as a whole. So let's start looking at a typical serverless application. We've got a very simple serverless application architecture, right? And we've got a to-do application example. So that is built as a single-page app. It's got maybe about four files or five files,
Really,
correct?
actually 2 files.
It's really 2 files.
app.js and index.html.
Right. So what we've done is we're deploying it into blob storage, and we use static hosting that's available in blob storage. So you think about it, it's a very simple application. You look at SPA applications these days, all the containers HTML, you've got CSS, you've got some bunch of JavaScript and some images that go along with it, right? That's all it has. And you really don't need the processing power of a web server to actually host these things. They're just basically static files. So we chuck all of these things into blob storage, and we basically expose it to the web.
In an enterprise, if you really want to do, you can actually put a CDN on top of that one.
Absolutely.
But for our case, we're going to do the blob. The CDN doesn't affect the security of it, but you might use a CDN. Azure has a CDN, there are third-party CDNs.
Yep.
You can do that.
Yeah. And you look at, and then we have an API that actually runs, right? This API is a simple Azure function, and this function calls a backend. The backend is effectively, in our case, table storage again, and we kept it really simple. Now, what we'll do is, this application, when we start with, it's not completely secure. So as we go along this talk, we'll make it more and more secure, and kind of like step by step, we'll show you how to actually fix the security of the application. So Pratik, you want to dig in and show the demo? So there are 3 things we want to show in the demo. So first thing is we're going to show the configuration of the SPA itself in blob storage and how we've actually configured it. We're going to show you how we are calling the API from the single page app, and finally how the Azure function is configured to talk to the backend. So we're going to cover those 3 things. Yeah.
One thing is that we have actually pre-provisioned a lot of resources in Azure, and I'm going to show mostly ClickOps through the portal or run some Azure CLI scripts. In a proper enterprise world, you probably will do a proper scripting or ARM templates or something in your DevOps pipeline to do it. You will not probably use it like that. The security concepts are what we're actually showing it here. So the first thing that was there was the SPA application and the function. Now, so this is a very simple function. It's called a to-do API, and the function is a HTTP triggered function. It gets the HTTP request, and it's connected. It's there's a table binding with the Azure table storage with a connection string. So that's our function. I'm pretty much sure you have all done a function like that, and it's got some method like get to do by ID, delete to do, things like that. So this function has been deployed to Azure function app, which I'm going to show it now. So I've deployed that function called it to-do API. It's got a few APIs in the function app, as you can see. The other thing that I have deployed is a single page application. Let's go to that one. So single page application is so this is a really simple HTML application. All it does is call that API using jQuery Ajax. You can use like Angular. There are some libraries that is available in Angular to do that one, but we have kept to simple jQuery. And so it is configured to call that function. This is the function URL. And functions has a very rudimentary level of authentication called function key. If I go to a function code, you can see that there's an authorization level.function. All it means is that the function key, you can think it of as a static key that needs to be passed to the function before the function will allow the call to proceed. Now, think about it. In a single page application, the function key is actually a JavaScript code. So this doesn't provide us any security. We have put that one here just to show that what is available is not good enough. You pass the function key. Either you can pass it as a query parameter called code, like $code equal to that key, or a little bit more security because sometimes query parameters are part of the URL. They can get logged and things like that. It's a little bit better if you pass it through a header called X functions key. So that's what is there here. On the Azure portal, so I have a storage account called NDC to-do SPA. In a storage account, if you create a V2 storage account, so this has to be a V2 storage. I mean, everybody should create V2 storage now. On a V2 storage account, it's got a new feature, but it's there for quite some time now, called static website. If you enable that feature, so that's been enabled, what it does is that it creates a special container in the blob called $web. So if you put any files in there, those files get served in a serverless fashion. There's no need to have any server in there. So it creates an endpoint for you. Now this endpoint is obviously like something .code.windows.net as a storage endpoint. If you want your own custom domain, you have to use a Azure CDN to do that one. because this comes with the standard domain that's available in Azure. And you tell what is the index document, so our case index.html, and you need to provide an error document, so 404.html. So what I've done is that in the app, so there's these 4 files, 404.html, app.cs actually got nothing, it's an empty file, app.js, index.html, and I've uploaded it to the $web container. Many ways that I could have done it, but I just used the Azure Storage Explorer tool in this case. So in this container, in the $web container of this storage account, I've uploaded these 4 files, so that's my SPA that is hosted in a serverless fashion. The function has already been deployed as well. So let's go to the function in the portal. So the function has been deployed. Now we all know a couple of things. One, for a browser to call a JavaScript in a different domain, the API that you are calling or the URL that you are calling needs to whitelist the origin. That's called coarse. So we have to first define a coarse rule to allow that single page application URL we have, so that the API can actually be called from the browser, because the browser will ask what is the coarse policy for this URL. So first thing you configure that one. So that's the coarse policy, cross origin resource sharing. So once that's configured, the other thing that I want to show is how we are connecting to the backend, which is the table storage, is really easy. So there is a connection string, there is a configuration environment variable really called to-do table storage. And what I've got is the connection string, including the primary account key to that table storage. So that's configured as a config variable or environment variable. So that's how this thing is working, very simple. So let's actually try this one. So one way that we can try it is using a tool. So I'll be using a couple of tools here. So just like very quick detour. So I'm using Visual Studio Code for the entire demo. Visual Studio Code has an extension called REST client. Think of it as a very simple Postman. Postman is very full feature, but for just calling get, put, delete, you can just use this extension right within Visual Studio. I'll close that one. It's called REST client. The other one is that I'll be calling Azure CLI, and there is an extension for Azure CLI where it understands the Azure CLI commands, and you can directly execute it from Visual Studio Code. So these are two sort of extensions that I'm using. So I've got this test client. So as you can see, I'm pointing. So these are like variables in this test tool. So the URL is the Azure function URL. So I'm just calling this URL with the functions key. I already got some data in the to-do table storage. So if you see the Storage Explorer, so there are some simple to-do items in here. They got a primary key to access that. So that's already been configured, and I've kept them in Notepad because I'm going to use them to test this thing. So let's just test this app. So there's a warm-up happening.
In true user fashion, you should hit it a couple of times.
Yeah. Well, first time you call a function, it has got a cold startup time, so that's what happened. But we got the result back, and so that's about it. So that's our first cut of the function. So at this point, we can see that the SPA is calling that one, but there's really nothing securing that API. If you look at the sources, which any competent developer or hacker would look at, they can see what's the function key. So that doesn't give any security. And if I use a tool, the tool should work as well. So if I just call this one, so tool gets it as well. So this function is kind of working. This app is working, but obviously there are some issues with this.
Yeah. So what are the main issues here? Particularly, just summarize that again. So
the main issue is that this API is actually open to the world.
Yeah.
There's absolutely nothing guarding it. You don't know who is calling this API. There's like anonymous access open to the whole world. So it's like completely insecure at this point.
Yeah. Can you switch over to the slides?
The coarse policy only secures the API getting called from your SPA application. But you can call an API using curl, using Postman, using this tool. So that doesn't provide any security. Yeah, you cannot create another sort of SPA application to call that API. That's true. But that doesn't mean that the API is secure by itself. So the coarse policy doesn't guard what you think.
Yeah.
Yeah.
So the way to actually start securing the application, the first thing is you want to make sure you introduce some kind of authentication.
Yep.
So only an authenticated client can actually call it, right?
Yep.
So let's go and talk a little bit about OAuth itself, because that's what we're going to be using to secure the application in terms of authentication.
Yeah. So we all know that OAuth, in this case, obviously OAuth 2.0, is the modern identity authentication authorization protocol that is used in web applications, mobile applications, and really. So the OAuth is basically a way where a client gets a token from an authorization server. That's a bearer token, which means the token contains all the claims that you need to present to a resource server to get access to a resource. So client gets this token from authorization server. So this is abstract term as per the RFC. We'll see what this actually means.
In fact, if you look at the diagram, the simplified OAuth diagram, you can actually understand.
So this shows that the client, in this case, the SPA application is the client that's running in a browser. It requests a token from an authorization server. We'll be using Azure AD in our example, but this could be Auth0, Okta, any other identity provider. Once it gets the token, it goes to a resource server. Resource server, in this case, is the API to get access to a resource, and resource in our case is to-do items. That's our resource, and obviously there is a person who is doing these things.
Yeah. So in this case, what the resource server will actually do is it'll validate the token. It'll look for it and make sure that the token is a valid one. If it's a valid one, it'll go grab the resource and then return it back, right? And we have various OAuth flows as well that we actually use based on the circumstance itself.
So the four most important ones is the authorization code flow. This is a three-legged flow where the client goes to the authorization server and gets a code, and then it sends to some sort of a backend application. So think of a MVC application where the controller can be that backend, and that again goes back to the authorization server with the code and exchanges it for a token. So in that case, the token is not flowing through the internet between the SPA application or a JavaScript application or anything on the publicly facing. So that's a bit more secure, but obviously you can't use it in a SPA because a SPA doesn't have a backend. Everything is running in the browser. The resource owner password credential is for legacy apps and for very trusted application like your like desktop apps running in your intranet, where the client itself takes the credentials like username, password, and sends it to the authorization server. It's not really used. And client credentials is really for like service to service or machine to machine communication, where there's a static username password used to get a token. What's important is the implicit grant flow for a SPA application. It's called implicit grant flow because what happens is there's a diagram from the RFC 6479 which describes OAuth. Very, very simple. There are a few actors in there. The resource owner is myself or the end user. The user agent is the browser. The client is the SPA application. Authorization server is Azure Active Directory, and the resource server is the Azure function. So all we do is that the client sort of directs to the authorization server, where the authorization server says, hey, I don't know you, give your credentials. You can use username, password, or MFA or any other thing to put your credential, and you are asking access to a particular resource or API at that point. So the authorization server will ask the resource owner, like the end user, hey, do you grant this app permissions? Do you grant consent to the permission that this app is asking? The app might be asking, like, I want to read, to do, delete, to do, whatever. So you grant the permission, it redirects you back to the browser, and at that point, you have obtained the token. Now that token is stored in session storage or local storage in the browser, and then when you use the JavaScript to call the API, that token is attached to the authorization header as a bearer token when we call the API, and that's how the API receives the token. And the token in this case is a JWT, or called JOT, which is a JSON web token. So it's a token that is basically a JSON, but it's base64 encoded into 3 parts, which we can show an example of a real JOT that we get from Azure AD. So this way, when the client goes to the API, we know that the resource owner, the end user, is authenticated.
Yeah. So let's do a demo of this itself. So the things that we're going to show in the demo is we'll add authentication using Azure AD, and then we also need to register our client application on Azure AD. So and then we'll have to make some changes in the SPA application. So now it starts to use the token that it's gotten from the authorization server, and we also want to, on the Azure function itself, there are a couple of things that we want to do. We want to make sure that we get the token that's passed across to us, and then we validate it to make sure that it's a valid token, and then we'll go and grab the resource, and then we'll send it back. And Oscar, like you said, we'll also quickly show the jot token itself.
Yep.
Yeah? Okay. Can you switch that? Thank you.
So a couple of things here. The first thing we need to do is that there are two applications involved. One is the SPA application, the other is the function. So they need to be registered as applications in Azure AD. So Azure AD is a concept of registration. Now I have already done this one, but I'll show how you can do it. For a function app, the easiest way that you can do it is actually built into the portal. So let's go back. So if you see this one, authentication authorization, there's a thing called app service authentication. We can turn it on and then choose Azure AD as our authentication provider. And when you go to this first time, the express thing will be sort of highlighted. So we just choose this one and we just say OK. So this will register this function as an application in Azure AD. And if you can see, it will get a client ID from the Azure AD. So this identifies, this is a unique ID for the client, which is in this case is our SPA application. The issuer is the, this is the authorization server, which this is my tenant ID in Azure AD. So this kind of says that it will be in the token, so that when you validate a token, you know that the token is coming from your Azure AD, it's not coming from somewhere else. So that's the things that you can check, that not somebody has got a token from somewhere else and just playing it back. So that's what there. Now client secret is not useful in SPA apps, you're going to ignore that one. So, and the other thing is that it also says what are the allowed token audiences, like who can get these tokens kind of thing. So that's once that is set up, there's a different view that you can see in the Azure AD as well. So I'm going to Azure AD, go to app registration, and we can see that the NDC to-do API, so that is registered here. It will be the same client ID that we saw in that portal, in the function portal. So that's there. The other thing is that when there's a concept that when you expose an API, you need to give it some scopes. So scopes is like the permissions that you want that client app to be granted by the user. So by default, when you do it through the function portal, it creates a scope called user impersonation, but that's just a default. You can create different scopes. I'll show an example. So you can add a scope, and the scopes are like a very common convention is a resource.action. So you can say, if you resource to-do, you can say to-do.read, to-do.write, to-do.delete, or you can do something like to-do.user, to-do.admin, depends on your naming convention. It's just a name, a scope, and you can say who can consent. Some very high value scope like deregister a user, you might say only admins can consent, so they will have to be admin in the Azure Active Directory. Or you can choose admins and users both can consent. Give it a name, give it a description, same for the user, give it a name, give it a description, enable it, and then add the scope. So I've already got a few scopes in there, but I've got the to-do.read and write disabled, but this is how I just create to-do.read. So you can create some scopes in there. The user impersonation scope comes by default when you do it through the portal. So that's just a name, that's all. All it means is that the client has got access to the API with this scope. That's all it means. So that's already done. The other thing we have to do, we have to register this SPA application. Now there's no sort of an inbuilt way to do that one, but what we can do is that we can just click this new registration button for a SPA application. We can give it a name, and we can say register. But I've already done that one. I'll just show it. So because it's a SPA application, there are a few things that we need to be aware of. Once you raise a SPA application, it gets its own client ID as well. So this identifies the client. The other one identifies the API. This identifies the client. In the API permission, you need to get a permission. So you can say add a permission, go there, choose your API, and you can see the scopes that are there. In this case, there was only one scope. I've chosen that scope and said, okay, I need this client needs this particular permission. So that's there. And the other thing is that in the authentication, you need to give it the redirect URL. So in our case, the redirect URL is where the Azure AD will redirect it back once it's authenticated. So that's the origin of this SPA app. And you need to tick, I need access token, I need ID token. So that's all configured now. So let's change the code and see. Okay. To restore. So that happens. So I've got the same application. What I've done is that I put this code in here. So I'm validating the access token that I get in the request. Remember, the token comes in the header. There's nothing special about it. It's just a string. And it gives the status code. I check the status code, and if it's wrong, I send a status code result, which will be like forbidden or unauthorized, something like that. If it's okay, then the functional part of the function works. Now you can use dependency injection in functions now to do some of these things a little bit more centralized fashion, but I've shown in a very imperative way how I can do this one.
And so, because we're doing it in an imperative way, we call it for each and every one of the functions, right?
Yeah. And the validated access token, what it does is that it extracts the token from the request header, which is the request header. Now it will validate some of the things like audience, the issuer, and the app ID. I have configured that already in the function of configuration string. So it gets it from the environment variable, those values that will be there in the JOT token, because I want to make sure that the JOT has got these values, that the audience is correct, the issuer is correct, the app ID is correct, as is expected. There is some SDKs for token validation in .NET, which you can use, and you can set the parameters to validate. Like, I need the tokens to be signed. I need the token to have a valid lifetime. I need to have an audience, which is this particular value. I need to issue with this particular value. And then what I can do is that I can send it to this JW2 security token handler and say validate this token with these parameters, and out comes a principal out of it, a claims principal. And then you can check what claims that token has. We'll inspect a token. Token has things called claims. And one of the claims that I want to check is that it's got the right app ID in there and the right scope in there. So I validate this thing. If everything is good, it's okay. Otherwise, it's forbidden. So that's how it's working. So if you see some of the values that I'm using is that I want to check this particular scope, for example. The other things are coming from the configuration here. So this is where I've configured the audience, the issuer, and things like that. So the audience is here. So it gets it, and so it's kind of coming from the configuration. So validate these things. So let me now deploy this function app. Let me see. Okay, that's good. So I'm building the function, zipping it up, creating a package. And now we'll deploy it. So while it's deploying, let me go back and let it deploy first. Actually, while it's deploying, let's go back to the SPA application. Now, this SPA application obviously has no way to, it hasn't got any code in there to get and obtain a token. So Microsoft has a library called ADAL, that's Active Directory Authentication Library for JavaScript, which sort of abstracts away this protocol for you through a simple SDK. And I'll be using that to get a token. So I'll go to that one. So the adult.js is now, you can get it from a CDN, but I have just added it to my application. And what it does, you configure the adult with, okay, what is my tenancy? So this is that my Azure tenancy ID we saw before. The client ID is the application ID of the client, which came from the portal. If we remember, it is the thing. It will be this particular client ID. So that's the client ID of the application. And the app ID is the client ID of the API. And we sort of, and the redirect URI is the origin for the window. So we configure these things. And what we do is that we create an authentication context. So we create an authentication context with that config, and the context is ready. Once we once we click the, let's go to the thing. So once we click the search button, what it does is that it uses the authentication context and first check if there's a cache token, because tokens are valid, bearer tokens are valid for a certain amount of time stored in a cache. ADAL can return it straight from the cache. If it's not in the cache, then it will basically acquire the token, and Depends on whether the permission is already there or not. You can also do a pop-up to get the consent for these things for the API. So once it gets the token, it gets a callback and it calls the search API now with the token, and all it does is that it adds the token to the authorization header as a bearer token. So you had the functions key and now we have added the authorization header. That's what will be in the SPA application. So let's deploy the SPA as well while we are talking. So I'm going to upload the new files, which is the app.js. The adl.js. And index.html file only because I had to add the reference to adl.js. That's why. Okay, so I've uploaded the changed files to static web hosting again. Let's actually try one thing, which is to check if this thing still works or not. So I'm going to call this one. So it's sort of spinning here. See, it didn't work now. It's 401 unauthorized. Why? Because I'm not passing it any token. So the function is now rejecting this call. So that's what's happening. Let's go to the actual app. By now, the function app should have deployed. Yep, the function is now deployed. So I'll copy this one. Open a private window. And I want to open a debugger as well. I take an example from here to search this. Now this will not work because I haven't logged in. So so the authentication context has no logged in user. Now you can redirect it back to a login page, but I'll just do it manually. I'll log in. So now it has gone to Azure AD. So this is Azure AD with my tenancy. You can see this is my tenancy in here. Let me log in. So okay, now I have logged in. Let me search. Fingers crossed should work. Yeah, it worked. So the way it worked is that I have got so ADL has obtained the token for me. Now in this case, you didn't see the consent screen because I've already done it once and that's recorded only once, but I'll show you a screenshot of how it looks like.
Maybe we can actually inspect the Java chart as
well. Yeah. So when you do initially, it will show you the scope. Now I added some scope, which I have now removed it, but at that time I had this scope. So it says that this app would like to get these permissions, which are the scopes, and then users say accept. Yes, I give permission to this app. This is recorded in Azure AD, and that's why it didn't come again. If I delete it using PowerShell, this will come back again. And yeah, as Mahesh said, how does a token look like? Now I have the token, I have actually written the token to the console. So this is how a JOT token looks like, and you might already know this. But there is a better tool than jot.io called jot.ms from Microsoft. A lot of people use jot.io. I like this one way better because this decodes it in browser. Your token is not sent back to a server, and it shows in a much better way the decoded token. So here you will see I got the audience, that is the API that I'm calling, the client ID of the API. I got the issuer who has issued the token, my tenancy, and I've got a few other things. The app ID, this is the client ID of the app, and I've got the scope, which was the user impersonation scope. So I've got all these things. This tool actually explains to you what each thing means as well if you don't know JOT in enough details. So that's very good in there. Any question? Yep. Yeah, you can do that. You can do that. Yeah, I just did it very manually to show step by step deliberately. But in a real application, yes, you can just call. You can straight away go to a login prompt.
In fact, that's probably what you would be doing.
Yeah.
In a real.
Or the other way is that you have the home page, and then somebody clicks the button, it pretty much redirects you to the login page, and once you log in, you come back. If you do Angular, these things are really easy because there is Angular library on top of ADL, which makes this thing very simple. Yeah, definitely. So that's how a JWT token looks like. And at this point, if anybody that has a token can still call the API, which I can actually show. But you need to get the token, and to get the token, you need to authenticate with Azure Active Directory. So that's a hurdle there already. So let's do one more thing. I go to test tool, and what I can do is that I can paste this and say, this tool is called auto completion. Yeah, authorization, BRR. And this thing. So because this is a bearer token, whoever has the token can use it. So in this case, I've sort of stolen the token from the browser. So this worked because the right token is provided to the function. The function is validating that it's got the checks in there. The checks passed, and I'm getting a response back.
Because you've got a secure network connection, no one else can actually steal the token midway and then use it. What are the, now that we actually implemented this, we're probably halfway there, right? What are the other things, what are the things that's still missing in terms of security for this one?
So one of the most critical things is that all the validation is getting done in the code within the Azure function, which means that if there is an adversary they can still get the function key from the SPA, from the SPA, JavaScript SPA, because that's still on inside the SPA. So let's go back. So you can still get it from the from here, and then you can start calling the function. Now, if you don't have a token, yes, the function will respond with forbidden or unauthorized, but you're still hammering the function. You are paying, the function will scale, you'll be paying, so you still got a DOS kind of scenario in there. The other thing is that this function key is embedded in a JavaScript. If you want to rotate the function key, which is a good security practice, you know how to redeploy your application, and this thing can get cached and other things. So it's got good to have your function key publicly available, and everything is getting done through code. So it's not the best state at which it can be in Azure, but it is obviously better than how we started, but we can definitely make it better.
Yeah. So one of the ways we can actually do is we can actually start to stick an Azure API management layer between our single page app and our function itself. So what this does is it kind of like acts as a gateway, and it shields access to the Azure function itself. And the other thing is, because now Azure APIM is available in a consumption-based plan, you effectively end up paying for just what you use itself. And the other thing is, like, if you noticed in the function that Pratik was showing, you had the validation of the token in each and every one of those functions itself, right? Yes, you could probably do some kind of a injection of it and then make sure that that's kind of like abstracted away. But it would be really nice if the Azure APIM can validate the token for you, and that's what APIM can do. And of course, as you mentioned, we can actually do the rate limiting itself to see, the number of calls that are actually being made. We can start to throttle that as well. And of course, one of the things that we'll have to do is we'll have to move the function key that you were talking about.
Yeah.
That can be moved over from the SPA and then be stored in APIM as well.
Yep.
So that's what we're going to do in the demo. So what we're going to do is we're going to publish the APIM in APIM itself. We're going to expose only the APIM endpoint from now onwards. And then we'll also configure the JOT validation policy. We'll set that up in APIM so that any function that actually calls it, we can actually use this policy to validate the token. And the last one is we can actually make some changes to remove the function key from the SPA itself.
Yep.
Right? And we can actually go and remove the validation in the Azure function, but we'll leave that out for the demo itself. Yeah? Okay, let's switch over.
Yeah, so as you can see, I've got a couple of API management resources provisioned there. I'm going to use the one called Serverless Desks from my previous talk. That's in a consumption tier. This is a new tier in API management where you don't have to pre-provision the resources for like how many scale units and that kind of thing. And this will pretty much scale automatically as more calls are coming through. It's got a few limitations today, but I'm going to use that for the demo. Some of the more complex rate limiting features only available in the more powerful SKU, like the premium SKU or the standard SKU. But it's good enough for our purpose. How you publish an API in APIM is really easy if you do it through the portal. It's like one click effectively. You can go to the function and you can publish it to APIM, or you can go to the APIM and bring in the function inside it. I'll just show you how to do it because I've already done it.
So one of the things that I will actually say that at this point in time, right, is although we are showing all of these things to the portal, in real life, when you're rolling things out, you probably automate all of these things, right? So just keep in mind, although we say it's so easy to do it, in reality, you'd probably automate all of these things through scripts.
I actually realized that this APIM is brand new, so this hasn't got this function. So let's just import it. It should be very quick. Okay. So what we do is that we go to this function app. It's got a workflow built in where you go and choose the function app. In this case, I'm choosing NDC API. Select that one. It will show me all the APIs inside that function app. I choose to bring all of them. So select. Okay. I can give it a URL suffix like NDC to do API if that's good enough. And I say, okay, let's create this API proxy inside Azure API Management. It will automatically do it, and what it does is that I'll show you what it does. Actually, let's go to the function. In the function, if we go to any one of these APIs, we go to manage. You will see all the function keys are actually here. So that action automatically creates a new function key, and it's called API NDC Sydney. So this is the key, that is that secret key that you need to call this function. And what APIM does is there's a thing in APIM called named values where you can store some secrets in there, and this is where it automatically brought that function key and saved it there. So it's kind of stored securely within API management at this point. And the API is here. Now, as Mahesh said, we need to validate this as a policy within here. Now I have pre-provisioned it, so let me go back to the API that is already pre-provisioned for the interest of time. The policies are pretty much XML files, and this can be, like at Azure, we are doing it in a DevOps pipeline through ARM templates. So that's probably the best way of doing this thing, but I'm just doing it to the portal for here. Let's actually make it a bit bigger. So we need two things. First, now the JavaScript will not call Azure websites.net, it will call Azure API.net. So I need to have a new course policy in here, because the course policy will now be returned by the API management, not by the function. So I put a course policy here which says that, okay, allow this origin. These are configured as named value pairs. So these are like configuration. So this will be that web.code.windows.net in here. And I say, okay, I allow all these methods and with any header. So that's course policy. It's important. But this is the policy that we're going to show, is the validate JWT policy. So the same thing that we are doing it through code, now you can do it through a policy. And it says, okay, validate JWT header, the name is authorization, and I want to check it should have expiration time, the token should be signed, it should have an audience, the value is configured, again it's a named value in there, but it checks that same audience, it checks the issuer, and it checks the app ID. So if all this thing is matched, then only API management will let the call to go to the backend, which is the function app. Otherwise, it will block the call and return from there. So this is where you get a very good protection for your function. Anything will be called API management, and this is a very much more scalable and a better layer to guard your APIs at this point. So this is already configured. All I need to do is basically deploy the SPA again, but now pointing to this URL. So the only thing that actually happened here is these two lines. So one is the API URL. Now it has changed to AzureAPI.net. Yeah, the one more thing I forgot is once you create in API management, you have a concept of product. So product is like a grouping of APIs. And what you do is that once you create a product, you create a subscriptions for the product, and that gives a key. Now this key is not really meant for security. It is more like if this key gets compromised, you can remove that key, and anybody that has that key cannot call the API. That's one thing. But more importantly is that you can actually rate limit by this particular key. So you can say that, okay, I'll give this is my premium product, and I'll rate limit it at a way higher rate, and you can create a like sort of a less premium product and say I will give this key to applications which can call much more less frequently. So you can do those kind of things with the key as well. So once I get the key, and the key actually can be shown here as well. We can show or hide the key. So I get the key. So that's the key that is configured in the SPA application. It's going to the API URL now. So let's just deploy this. Yep. So I'll upload this changed application now. Cool. I'm going to close this window and relog in. Actually open the network tab. So if you see that pop-up now, it shows it's calling azure-api.net. So it called through the Azure API Management Gateway, and the function key is not anymore in the SPA application. That's been guarded by API Management, and we are validating the JOT inside API Management now. If you hijack a JOT from somewhere else, or it's expired JOT or anything like that, the API Management will reject that call and not let it pass through the function backend.
Yeah, I think someone's got a question over there.
Yep. The code for validating the token is still there. I'll probably say that we can still keep that one, and the reason is that I'll go to there's a few more things that we can do with that particular token, which I'm going to show. So it's better to keep that code for now in there within the function. Now, obviously, you can relax the validation to some extent because you know that it is getting validated at the like you might not check the audience anymore. Some of those things you may not check. The sign you may not check the signing, because for the signing it actually goes to the Azure AD to get the signing keys to check the signing is correct. So that's a bit of a slow thing in there. It does cache the signing key, but it is a bit slow. So you might relax some of this validation, but it's good to keep that code in there for some other reason, which we're going to show very soon.
Yeah, and I think we're kind of like running out of time. There are two additional steps that we want to that we probably need to do. If you look at the security of the application so far, right? I mean, we kind of like made it more secure from where we actually started, but there are two things still missing. One is, authorization. Right? We've added authentication, but we haven't done any authorization on it. And the other one, we'll probably combine 6 and 7 together, is the fact that there's still some credentials sitting on it. We have like a connection string that is sitting on it, and we want to secure that. So first and foremost, we want to do this in the demo itself. We want to kind of like add roles in the AD manifest itself, and we want to make sure that we grant user to the role and check whether the validity of the role itself. So in code, we want to make sure that this user can execute the code.
I think in the interest of time, we might just show the code this time and not deploy. And
that's right.
Because it takes a bit time to do this part of the demo.
Okay, cool, right.
But what we have done is we have got an authenticated user at this point. So what happens is anybody in your Azure AD or in your Auth0 tenancy or whatever can authenticate, and it can grant these particular scopes. But what we're still missing is that, okay, I know who you are. The application knows that it is this person that's been authenticated. But what I don't know is that what are you allowed to do? So that's authorization. Because it might be that some users are only allowed to list, search to-dos and maybe create a new to-do, but they're not allowed to delete or update a to-do. That requires an admin user. So we don't have that concept yet, and we can bring that concept in as well. So for a long time, we have been doing authorization through role-based access control. So you can introduce a concept of roles for the application, and we can grant user certain roles, and those roles will come back in the claim, and in your code, you can check in that those roles are present or not for certain actions. Because this is semantics that the API management doesn't know, because that's just a layer to validate the token is there, but what it actually means, that's for your application. So instead of actually deploying this, I'm actually going to show you how that can be done. Yeah. So the first thing that we need to create roles. So in Azure AD, we go back to Azure AD. So if I go back to Azure AD and let's go back to the API. So Azure AD has a configuration object called a configuration JSON called manifest. Some of these things you could do through the UI, but other things you have to do it straight away in the JSON. So what I've created is that I've created, this will be empty. So this app roles property would be empty in the JSON when you start, but you can create roles and they are defined like this JSON property. The important thing is that you give it a name, you give it a unique sort of a key called NDC to do API user, and you need to get a new GUID you can generate using PowerShell or any other way. You need to give it a GUID and some description, and you say that the allowed member type is user. You can also have application roles, but they are for machine-to-machine communication. We are talking about user roles here. So I create two roles, NDC API to do user and NDC to do API admin. So these two roles are created. Then what can I do? Let me go back to my enterprise applications bed. I go to the API, and here you've got users and groups, and now I have added two users in. So I've got a user called to-do admin, so I can do add user and I can select. Now if you've got a Active Directory Premium, you can actually use AD groups as well. Mine is the free AD, it doesn't come with the groups and some other things. But you can say that, okay, I select a user, and in my tenancy there's some users in there, so I can again select like to-do user in this case, and so this user will be in this role for the application, and you can grant, an admin can grant this thing in the AD. What happens is that when you get the token the next time, these roles will be in the claim. I'm going to show that one, but I think I had a jot with these roles, so I'm just going to, I've saved it, I'm just going to show it in the tool. So in this case, you have this role here now, because a to-do user has obtained the token. The role shows that this is the NDC to-do API user. That's the role. And what I can do is that in my API code, let's go to the final version of this thing. So now I can check if the principal is in role, and I give the role. Now these roles are different for different actions. So if it is like I get the role in the validate access token now, I added this parameter to this one. Now if this is a like a delete action, I'm saying that I need the admin role, which is the string that is configured as a constant on the top. Or if it is the get to do, I only need the user role. So you can validate what role you want for different actions as well. So that gives you the authorization at this point. So I'm not going to deploy this code, but you can do this one. The last thing that is missing, as Mahesh pointed out, is that we got one more. So we have secured the connections pretty nicely between the SPA application and the API. You can do a little bit more, like you can, because now that we got the API management in the middle, you can also secure the API management to the function using a client certificate and mutual TLS for an added layer of network protection as well. You can do that one. What's still there is the connection string that is between the application and the backend. Let's look at the connection string again in the portal.
Yeah, I think we can switch back to that.
Yeah. So as we saw before, the connection string is actually stored in the environment here, which is this one. So it's got the whole thing in here. Now we know that environment variable configuration, sometimes they're not the best place to store secrets. There are many reasons for that. One, anybody who's got access to this particular Azure resources has got access to this one. Oftentimes you want to keep the secret in somewhere else where only a very few people, like a security operations team, or very few people have got access for those things. The other thing is that if you want to change these keys, these keys, let's say you've got many applications using the same table store, you need to go to each application and change it there. Key rotation can become important for certain security practices, keys gets compromised. The other things are down, every time you're using a key, you have no idea who is actually using it because no logs of this thing. So in Azure, there is a special resource called Azure Key Vault. That is a recommended way to store keys and secrets. This is a secret. So secret is a name value pair. The name is this name and the value is this. So we can store the secret in a key value in Azure Key Vault, and there is a way that functions has got first-class support for obtaining this from a key vault, and that's what I'm going to show now.
Yeah.
So let's go to a key vault. Let's go to key vault.
So we've run out of time, so we're meaning to just.
Yeah, we go very, very quickly.
Yeah.
So we've got a key vault in which I've got a secret in here. So the secret is that connection string. So that is the connection string, and the name of the secret is to do table storage. And every secret has a full-on URL, like a canonical URL to that whole thing. And the other thing we do is that, let's go to the function back again. In a function, you can give a function a managed service identity in Azure. This basically creates a service principal for this function application inside Azure AD, where the way it identifies the function. If you turn that on, you create a service principal, and an identity is created for the function. What I've gone and done is in the key vault, so let's go back to the key vault. In the key vault, we go to access policy, and we add access policy. If we add this one, we can be very granular. So you can say, all I need is get secrets, that's all. I don't need anything more than that, just one permission enough. And I select the service principal by searching it in my Azure AD, so I'll not show that one, no time. So we have done that one and say, okay, NDC to-do API application has got get permission for secrets, that's all. Then what we do is that there is a, let's go back. So there's a special sort of a format in which you can store the because the connection string is now in a secret. What you can do is that you can set the key vault connection string, which looks like this. Microsoft.keyvault secret URI is the whole path, the whole URI to that particular secret. And then you store that as the settings which we had before, the to-do table store, same settings, but this time we're going to store it like this. Now, because we run out of time, we're probably not going to show this one. Yep. And I find sometimes it's good to restart the function up after that. But now the connection string will be this. It will not be the actual connection string, it will be this connection string. And function API knows that I have to go to a key vault and get the secret, and because it's allowed by the access control policy with its own identity, it can do that in the background.
And only that Azure, only that function can actually.
Correct. And this is called credential-free code. So it is a very good security practices to not have any credentials in code. In this case, we have removed all the credentials, and that's how it will work.
So we kind of like run out of time. So one of the things is like we've got an overview slide, talks about all the things that we've actually done. We will actually publish the slides itself, so you can actually have a look at it. So we were originally going to walk through the whole thing, but we run out of time. You know, I'm happy to. Both of us are happy to stay back and take questions. You can also reach out to us. The slide actually has our email address and Twitter handle, so feel free to you know, send us any questions that you may have. And on the way out, you know, please fill the feedback as well. Yeah. Yep. All right.
And this is the last session of NEC, so great thanks to
all
the people who have come to the conference.
Yeah. That's right. And thanks to the organizers and everyone else. All right. Thanks, guys.
Bye.